When I first started making multiplayer games, one of the big appeals was the simplicity. You just have to make the player character and then you're basically done. In contrast, single player games require like a whole host of enemies, bosses, each which have their own unique code, models, and animations. As it turns out though, what time you save on content creation, you spend just as much, if not more time, fixing networking issues. At first, I was using Godot's built-in networking socket to handle the multiplayer stuff in my game. It works perfectly fine for most projects. I decided to switch over to Steam's API though instead. Steam offers a bunch of features that make multiplayer way easier and more efficient to set up and manage. To make this switch, I use something called Godot Steam. It's a custom version of Godot engine that already has Steam networking API stuff built in. That means I can just directly use Steam's tools without having to mess around with too many third-party plugins or complicated setup. Normally, if you want to let players host their own servers, there's a lot of work involved. They usually have to go into the router to set up the port forwarding, which can be a nightmare if your brain is on the average level of a PC gamer. Plus, they need to launch a separate program to actually run the server, which isn't exactly user-friendly. But with Steam, hosting becomes something anyone can do. It uses a thing called NAT punch-through, or at least it probably does. It allows players to connect to each other directly, even if they're behind different routers and firewalls. So no more looking up YouTube videos on how to start your Minecraft server. Because of this, literally anyone can host a server, which opens up hosting to a much wider audience, which is great for building a community around your game. Now, these peer-to-peer servers might not be as fast or stable as dedicated servers, but they do have huge benefits. With this setup, your game doesn't rely on official servers to stay active. A lot of modern games miss out on this, and it's kind of sad when you think about it. Once the official servers are gone, so is the game, because nobody will be able to play online anymore. But if you set up your game with the Steam API, your game can keep going as long as people want to play or as long as Steam servers exist, which I think is pretty cool. People can be playing Wizards and Shorts decades after my lifespan when I've already passed on to the great beyond. People can still play Wizards and Shorts. However, the Steam networking did add some more latency, which unearthed some bugs in my networking code that I discovered during playtests. I have 3 bugs I wanted to cover for this video, and I wanted to show you kind of my process for debugging them. The first was the most catastrophic to gameplay. Sometimes a player's connection would go bad and their wizard would become invisible to certain players. This allowed them to go around the map completely invisible and invincible. However, for some reason, they actually could be killed if the other player went to the position 000 on the map. Since the wizard positions were not syncing, their wizard was stuck at the spot and vulnerable to being killed there. The player has 2 parts. First is the input handler, which manages all player inputs. And most importantly for this bug, it manages respawning and despawning. Each player also has a wizard attached. The wizard has the bulk of the code. It manages movement, acceleration, velocity, has all the weapons attached to it and health and mana. When the wizard dies, the player will manage despawning it and respawning it. When it despawns it, it will fully destroy the wizard, and respawning it will fully create the wizard. The reason I fully destroy and recreate the wizard all the time is just to make sure it's all the way reset. To make sure that these connections are synced, I use RPC functions in Godot. These will call the same function on every single client so that I can sync respawning and despawning. It is entirely possible that that is where the bug is happening. If the RPC function is not being called, then there will not be a wizard to actually be visible on that client. Luckily, when I configured my game, I had the foresight to enable file logging in the settings. This will dump all the console output and errors into a file on my playtester's computer. After explaining to my friends how to access their app data folder on Windows, I was able to get them to email me the logs. From the logs, I can kind of determine that it is actually most definitely that the RPC function is not getting called. So instead, I decided to replace it with the multiplayer synchronizer. This is Godot's built-in solution to making sure that an object is, if it is created or destroyed, it is passed to every single client connected to the server. It should automatically manage the creation and destruction of wizards. I'm not really sure how multiplayer spawners work in Godot, like under the hood and stuff, but I was hopeful that they would resolve the syncing issues wizards were having, but it sort of just happened again. For some reason, the same error would happen occasionally, after level switched, and all wizards were respawned in new positions. I don't know if there is a packet loss or something that changes the names depending on the client, but the ship broke and the data is not syncing. Then the solution came to me in a dream. Why am I creating and destroying the wizards all the time? I should just use one wizard and add code that resets it between rounds. I originally was creating and destroying the wizard objects because it made things easier, but at this point it's clearly making things so much harder, and I've spent hours debugging it already. So let's make one wizard. Instead of trying to synchronize all the creations and destructions, I just wrote some simple code that resets the variables and fixes the ragdolls that occur when a wizard dies. Now that wizards are not being created and destroyed, it should be impossible for them to desync, right? Wrong. For some reason, I think the desyncs got like even worse. I don't know why. So I had to go back to the drawing board yet again. So on my main scene, I was using one multiplayer spawner to create the players and the levels, but instead I broke it down into two, and one of them is the level spawner and the other is the player spawner. So on the player spawner, instead of just using the default spawn function, I was able to overwrite it based off of a random GitLab or GitHub post. I saw that they were having a similar issue, but not on like the Godot Steam side of things. So I made my own player spawner script here that just overwrites the spawn function of the multiplayer spawner. And all it does is it spawns a player scene, and then it sets the authority for said player scene. And it also sets the names to the ID of their socket. Then it returns the player. And for some reason, I think that this fixed it. I did play tests with my laggiest friends. I did multiple play tests, and I haven't been able to recreate the desync. So fingers crossed that it's fixed. It's possible that like using the multiplayer spawner, not overwriting it, that there's like a race condition or something, and the child doesn't always get added to the multiplayer spawner, so it doesn't end up. I don't know why. I don't understand this actually. I don't even want to begin to guess what the reason is, but it's there. So debugging all this, I learned a lot how multiplayer works in Godot. I also learned not to try and band-aid fix networking issues because latency will pull that open at the cracks. It was very stupid to not try to reset the wizard manually from the beginning instead of destroying it and creating it all the time. I don't really understand how I ended up fixing the issue also with like the multiplayer spawner thing, but here we are. My game is very bug-free, kind of. I've lost hours of my life working on this networking. The next issue that I encountered was not as game-breaking, but it did make one of the weapons entirely unusable. I wanted to add the equivalent of like a sticky bomb in my game. It could be fun to launch them around corners and put them in places your opponent would not expect. To make it a little more fun, instead of sticky bombs, I designed this explosive green pufferfish in Blender. The plan was to make it a rigid body that rolls around and explodes when a player comes within a certain distance. This had two main problems though. First, I didn't want the fish to explode immediately after the wizards fired because they would be within its radius. Because of that, I disabled its collision when they were first fired and then re-enabled it after a set time. That time had to be really low, otherwise you wouldn't be able to hit players at close range. So I set it to 0.1 seconds, which in my testing worked pretty well. But when I tested in multiplayer, the added networking lag made it so you would pretty consistently end up just killing yourself. You would fire and then it would immediately blow up in your face.
You need to spawn it further away from like the character.
I fixed this by giving a much more generous timer that only made the player who fired it immune. That way, it was less likely it would explode immediately and they could still hit other players at close range. The other issue was they were physics bodies, so it was very difficult syncing the position and rotation across clients because rigid bodies kind of just do whatever they want and you can't really bank on them doing the same thing every time. Because of this, I just had the host calculate the physics positions and send it to all the other clients. This works great until the host has a laggy computer and the fish looks like a slideshow moving around for everyone else. Just going like, bah, 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 bah. I don't want any of my code to rely too heavily on the host having a fast computer and connection, so I made the flying fish bombs have predefined paths that any client could reliably calculate on any given frame. It's sad they don't like roll around anymore because I didn't like code in like a complex physics system, but I still think it's cool, and I think the trade-off is worth it so that the game is still playable even if the host is not very fast. To me, it's kind of insane thinking about games like Siege that are able to sync environmental damage and destruction across multiple computers. There were probably so many bugs when they like first initially tested stuff like that. The game would be literally unplayable though if that wasn't synced exactly the same across every computer. I don't know. I don't know how they accomplished that. The last issues I had with networking didn't really affect gameplay. It was like 1 in 10 times somebody would try to join, their screen would just turn completely gray and never load. They'd be forced to restart the game and try connecting again. In the console, a bunch of errors that were mostly non-descriptive would be printed. My initial idea was to start a timer every time someone tried to connect, and if they were not able to connect by the end of the time, I would boot them to the main menu with some error message. This didn't work at all because often they would be able to connect to the server, but some step in between the connection and the player spawning would fail, so the error message never actually printed. Instead of reinventing the wheel, I just read documentation. I read some of the Godot Steam documentation more, and I figured out that there's an event that runs whenever a connection fails for any reason, and I completely ditched my previous timer. I just hooked up that method that I had already made to a pop-up to their like signal for whenever something fails. Whenever there's a connection timeout or an invalid thing, it will just bring them back to the menu, or they have the option to reconnect. I also made a simple loading animation so that they knew what was going on in the background while they connected, instead of just having a gray screen. I don't know why I assumed initially that the Steam API wouldn't have something like that, and why I attempted to like write my own timeout. Let this be a lesson to all developers. Critically think about the possibility that the thing you want to do already exists and it's already implemented in some function or library your game's already using. Just learn to read, probably. I'm still getting like some networking issues and stuff with the pop-ups and some occasional stuttering and stuff like that. But with most of that out of the way, the bugs mostly fixed, I think my game is now better than, or has better networking than Counter-Strike 2. I hope you enjoyed me sharing how I worked through the debugging process for these bugs. I was thinking about how that's sort of an underrepresented part of game dev YouTube. Usually they just show like a clip of the bug and it's like, haha, so funny, look at this bug that I had that I also solved, but they don't tell you like how they solved it or like anything else. I think it's good to see all the things that people tried and like their thought process for debugging, and you get to learn how like stupid I am. So yeah, cheers. I just got the Steam page set up, so I'm not, graphic design is not my passion, so be kind and yeah, wishlist it. So when the game comes out, I'm shooting for the end of this year. I think I'll be able to make that time. Yeah, make sure you wishlist the game and subscribe to the channel as well if you want more dev videos. Thank you. Bye.